Lovely people, good morning. Let's jump right into it. I've had an engineer, so you don't have to out yourself. I will not. Tell me that I should do more statics and do more things like that. They're thinking that because I don't mention statics in my formulas and calculations to you guys, my extrapolations, that you can't be an engineer because you don't talk about statics. Okay, I accept that challenge, and I'll show the defect of using statics in engineering. And that's because it's like a hammer. All right, so you don't have to believe everything you're taught. So you were taught Big Bang Theory. Religion was taken out of the school. So Big Bang Theory. So you were taught that two rocks in space did the bang bang, and made soil, grass, trees, an ecosystem that's perfect, dinosaurs, humans, which incidentally dinosaurs and humans appear not to be together on the planet at the same time, although cartoons may put them together, the birds, and if we're evolving, where do we stop? If you believe in evolution, where do we stop? At what point do we stop? Are we supposed to become birds? Which is the greatest thing here, evolution-wise? Oh, wait a minute. The two rocks doing bang bang wanted to make brains the highest on the evolutionary scale, since you're doing the Big Bang and evolution, right? So the two rocks ultimately wanted brains. They started with no brains, but they want to evolve to have brains. And they made a dolphin that sort of stuck him. That's the human's version of the ocean. In the ocean, right? So the most intelligent one out there, supposedly, that and a couple of whales. Well, all right. I don't believe in the Big Bang Theory. I don't believe in evolution. Now, I do believe you can change things by clearly putting a red rose and a pink rose together and come up with whatever you're doing. You can cross-breed whatever nature will allow you to cross-breed. But unless you change nature, you're not going to cross-breed it, nor will you be able to give me, for example, a heart from a pig. Unless you change its DNA to be able to take my DNA, to accept my DNA, or not, my DNA not to see the pig's DNA as an attack, which they're working on now. It's interesting. And you can go with CRISPR. If you guys want to get deep, you can go look up CRISPR and things like that. So I'm going to get to this. So the statics is a failure. It's a carpenter looking at everything as a hammer, or that looks like a nail, I better use a hammer. All right, statics don't work. All right, statics are something that's a failure. Now I'm going to prove statics is a failure using what they used to the FIU Bridge. They used calculations in a computer system that used statics. They came up with, and thousands, so I'm the only one nut job is saying it wrong. So thousands of engineers have said and agree with, through not disputing also, that this is slide fiction, that this is the number 11, slid off the number 12. Thousands, right? In the computer system too. The statics, the computer system, it all says it. Look how simple this is to prove the statics sliding this off is just bullshit. So I'm going to take a screenshot of it first. Wait a minute, maybe I can download the image. Let's see. So save image or open image. Save image is a download. So and download, right? JPEG. Let's do that. And let's open that download up right here. And oh, great! It's going to go over top of that, and I wanted to use that for a video. All right. Well, so much for that. Oh, that's small. All right, it works. It's going to have to work. So then let's go to let's do this. So there's the number 11, and it pushed this number 12 off. So this is number 12, right? So this is number 12 here. Okay, so let's delete that. I should have covered it with a should have moved it with the hand like that. All right, let's just extract. Let's just make it larger. But I'm going to make it around the bottom of this pixel here. And then this is number 11 right here. This is 11. And it's got some interaction, roughly like that. This little cant, if you will. But this is number 11, and it's flat like that. Let's now go ahead and delete it now. So you see how number 11 is on a taper, if you will, like this. So let's make that smaller, significantly smaller. So number 11 is on a taper like that. Let's do 11 over here. This is not number 11, but it looks like that. Well, not quite. I've got enough time in this to do it better than that. So it looks like this, actually. And these are blister bars up here, they call them. But it has this shape here, and this is supposed to stop it from fracturing as much. These little nodules here, these little weird details like that, odd details. How's that? And so what matters is that you're looking at this. That's the internal part, this one here. This is the one they're saying slotting the base. This is what they're saying slides. The slide is slid there and pushed number 12 out. And that's because the hammer, they see some ejected material here, and they're like, oh, yeah, that means it took an impact. Well, think about that. You ever pound a wall on this side and you get the other side to eject off? Imagine the force to get that eject off into the air. Or simply, did it something spall and eject off in this location? But no, they got it flying in the air. So it's got to be the base there doing its thing. Now let's show how simple this is to show that slide cannot take place. We'll grab one of these things here. What is it? Oh, no, we want that one. Wait a minute. I got ahead of myself on my own joke. Where are you? Huh. That's like an oval. Yeah, it looks like an oval. Not what I wanted. It's an oval. What the hell's a circle? Interesting. I can use this circle from here, though. So this is a circle. All right, it's a magnifying circle also. You got to be kidding me. I can't make a circle smaller. Yeah, that's got to be a joke on me. All right, let me see if I can draw a circle, and then it will change it to a circle. Yeah, it did. All right, so now grab the circle, and I'll bring it down here. And I'll make this one point hit there. Let's see, I'm going to make the circle, and the circle will get larger. Nope, not proportionally. Let's do it again. You'll see where I'm going in just a moment. Really? It's like, that's not a circle, dude. Okay, let's try again. It's kind of hard to do a circle. Let's see if it does it. Okay, there's my circle. Okay, so here's where the circle is hitting. Let's do this. This is where it's dissecting the 2 points. So I got to do it like that. Sorry. Yeah. Let's change the color. Let's go with the red if they got it handy. Yeah. Let's do that, and let's do this too. And that's where it dissects. Let's do another one at the top. And that's where it dissects there, 2 points there. Now you see, this would be the number 11, the number 11 diagonal. So here's the number 11, and maybe I'll kick it a little more like that. There's the number 11 diagonal, and maybe we'll kick that over a little bit that way. Kind of make these parallel, these lines, so give it an illusion of parallel at least. There we go. So you see what happens here is that put that back at the bottom of the circle. This is also pinned up here at the top. Nowhere did they talk about it losing its fixity at the top. And so it didn't lose that point. And so now it's going to now elongate to slide number 12 off. Number 12 here. Okay, make this slide. Looking at it, make it slide. Well, you'd have to also believe in two rocks banging that makes dirt, an ecosystem, a perfect ecosystem, and well, perfect to its life cycle. Birds, trees, fish, oceans, everything, just by two rocks colliding. That's the most ludicrous thing I've ever heard. Now listen, one of the most ludicrous things. So facts and science. So facts are facts, and science is what scholars look at the facts and try to make a science out of those facts. Whereas it's just a fact by itself. I am talking to you. That's it. Now, if you're trying to extrapolate what I'm saying from you, now you're making your own little science, if you will. So I'm just talking, in other words. The fact is, I'm just running my mouth. Right, so now, and then you can say, well, another fact is he said he's running his mouth. All right, you take it out of context, you can switch it up to be, he was saying he didn't know what he's talking about. He said he's just running his mouth. You see, I can take it out of context, or you can say, you can give it its true context and say he was trying to explain what was going on with the facts versus science. So you can see how science can change the true data, the true facts. So science says that this number 11 pushed off number 12 when they were post-tensioning this. So post-tension, they were putting compression inside number 11. So they were putting compression. I didn't say they were pushing it. I didn't say they were pushing it off. I said they were making it tighter. They were putting compression inside this number 11 at the time, making it shorter. So, it changed its own arrow, didn't it? So they were putting compression inside here, making it shorter, making it so it would not elongate. So hold on. They 100% said they were making it so it would not elongate. All right. Remember, they said slide friction. So they're not saying number 11 is bad. They're saying number 11 is still in place. They never said number 11 was all fractured to hell and there's no way that it could push anything off, because in reality, number 11 was fractured all the hell. You can look at my videos of it. That's what was fractured when they detensioned it. And I know how it got fractured all the hell too, detensioning it. So that was on the Saturday, I believe it was. Saturday? Put it up on Saturday, fell on Tuesday, something like that. So the 4-day bridge or something like that. So do you see the circle? The circle's there for a reason, because that's the radius. From here to here, if you start swinging up this radius, it will get closer up here, and it would go into the column up here. But down here, it can't elongate. It can't. See, the circle goes away and around. It can't elongate. It could lift it up, but it can't elongate. But wait a minute. Remember, they were putting compression in this member, not pushing it away. Now there was an anchor point here inside the diaphragm. That's the base of this structure here, where they were anchoring to be able to put compression in it. And there was an anchor point up here, the blister bar. And they put tooling on it, and they tooling on it, which allows it's a bar, not a cable, to be compressed, to put tension in the bar that would not allow it to elongate. And there's like a giant nut back here and a giant plate washer, if you will. And literally, there's a giant nut back here, not figuratively. And there's giant's figuratively, and the nut's real. It's a big nut. Goes around the bar, right? 2-inch friggin' nut, whatever it is, 3-inch. So outside, roughly. So, and then up here, they grab the bar, the tooling, and they stretch the bar. They stress it, and then they tighten down the nut, and then they move back and forth. There's two bars in there going down at the time. 2 bars, one in the diaphragm and one inside the sort of the back high part. One's pretty close to the embedded inside the number 12. So they create their own fracture plane. I call them shear planes. That seemed to piss off somebody too. Well, fracture plane, all right? They exist. Whether you like to believe it or not, they exist. When you overlap your bolts, they're too close together, and you put tension on them, you'll just cause a fracture in concrete. That's it. There's no ifs, ands, or buts about it. The stresses on them will fracture it out. If you don't understand why, well then simply, I got to remember to remain calm. Simply just think of it as a wedge. It's just a wedge. Those nuts, and they create a cone failure. But let's add. So let's just work with the one bar there. Now, putting compression in these bars relates to them as putting extension on the number 11 that allows it to push off the number 12. Here's the number 12. And by their statement, NTSB, that when they were compressing this made number 11 slide off the floor here, if you will. Slide. And it pushed to number 12. It can't do that. Number 11 is fractured all to hell, for one thing. It's physically all fractured to hell. The loads on it would just cause it to split. Not carrying the loads, transferring the loads. So if you don't transfer loads down number 11, well, where do they go? Well, they go down number 10. This is number 10 right here. Let's get rid of this junk. This is number 10 right here. The diagonal. That's number 11, and there's the number 12. Since number 11 is now fractured all to hell right back here, the transfer of the loads go to the base of the 9-10 nodal area, which is right here inside the deck, because you can't transfer down there. So now you have a top canopy that's trying to hold it up in a strong back fashion. A strong back fashion down the number 12. It's only got 2 bars in it total, tension, not bars, tensioned cables in it at this point. I think two are loaded. And down here, so it's trying to get down number 12. So this creates it's a rotational torque that took place on this also. It's evident in the photographs where you see when you look down from the top view, you see the fracture from top view down. At the right side, using a tape measure that they used, you can see it's higher than the one to the left. By default, that shows you that looking at the top of the from this direction down to here, there's a rotation in that capacity, clockwise rotation. And so that rotation took place. There's a torque in this created by the post-tensioning inside these that they didn't calculate for, that there would be some rotational torque and twist. And they then run it down the one column only, the number 12, the one pylon, or I think they call it the pylon, the number 12. It doubles as the pylon for it. So the number 12, it's got a crack in the deck there. So the number 11 is not taking it. So then we get to the base, right? The span. So we're taking it down number 11, down number 10. 11 is fractured. And so where are your loads? This is all, turns out this is all rigid. This is working pretty good rigidly. It's probably creating a torque for you though on the back end, but it's rigid. It's all together. How do we know that? When you look at the video collapse, if you slow it down, which I did a million times, that's figuratively, you see the deflection happen right about here and here. So using it to using it here, that means the loads were here. This is the fixed point. This is all rigid. And from here to here, it couldn't take the loads as a plate, if you will. Now, Denny Pate, Linda Fig, they said that it's all the bottom plate. It's just like a bottom piece of steel that's real taut, and it's H-beam, but a caveat is that you really don't need the roof. This is a tire compressive system. It's not a truss system, they stated. It's not a truss system. That it's an I-beam, a giant I-beam, but with that in mind, the top flange is not structural, that it's not needed to make this work. That was part of their own statements. It's not needed, so it's just a plate. And I theorized that in one of my first videos. Oh, did I get beat up by a million people on that? You don't know what you're talking about. It's a truss. I'm like, well, it's not a truss. What if? I said, what if this was just designed to be decorative and it's just post, and I didn't see all the compression in it yet. In fact, I drew something showing maybe this one's tension and maybe this one's compression, and then I finally said, what if it's just a plate? It's just a stiff plate. All right, and that's another one of my videos where I talk about that, how things should really behave, and that's why I have that knowledge on that. So and it turns out that's all they really wanted it to be. But then, during the failure mechanism, they now talk about slide friction. And I'm like, well, wait a minute. Now it's acting as a truss. Because now you're saying it's in compression. It's in compression in the capacity that it's being pushing out number 12. Remember, it's pushing 12 away in their theory. So it's a compressive member. But if it's a compressive member, why were you adding compression in it? It was already under compression. Per their theory, it was already under compression. So using their theory of it's under compression, I wonder if this mic is working. Testing, testing, testing.